Hi, it's Nehemiah from Special Science School. We're looking at this concept in chemistry: atomic number, mass number, and atomic mass. Many folks or many students misplace these concepts together. They think that mass number is atomic number. In a nutshell, we're going to explain the whole of these concepts. Now we have the structure of an atom, which looks like this and like this. Okay? Now, in the structure of an atom, we have the nucleus inside the structure of an atom. Meanwhile, nobody has seen an atom anyhow, but by chemistry, discovery, and presumption, we can say this is the study, this is the structure of an atom. Now we have this. This is the proton inside the nucleus of an atom, which is positively charged. Then we have the neutron. Neutron inside the nucleus of an atom, which is zero charge. It has a zero charge, it has a neutral charge. Then, if you want to study more about our concepts, we're concentrating on these concepts. Let's just add these electrons. Let's add up these electrons. So these are electrons. Electrons is negatively charged, and this is the orbit or the shell which the electron resolved around it. Now, meanwhile, we want to look at the concept atomic number, because that's the first thing there. Atomic number is simply the number of protons only. So, protons positively charged only. Atomic number is the number of protons only in the nucleus of an atom. When we talk about the atomic number, you'll notice that if you know the atomic number of an element, you can identify with specificity what element that is. The element could be hydrogen, could be chlorine, could be sodium. If you can identify the atomic number, you can identify that element. So we're looking at the atomic mass. If you want to look at the atomic mass, let's specify with this illustration. Let's say we have these elements X and Y. This is element 17. This is element 17. Atomic number 17, mass number 35, mass number 35. Now, why do I call this mass number 35? Mass number 35. Let's call this 36 now. Let's make this 37. Sorry, not 36. I have a fainting pen. Let's say this is 37. Now, if you notice, I call this mass number. I didn't call it atomic mass. I didn't call it atomic weight. You see in some textbook, it's either called atomic mass, atomic weight, relative atomic mass, or average atomic mass. But meanwhile, the atomic mass, or relative atomic mass, or average atomic mass is not the same thing as atomic number. As mass number. Mass number is a whole number. If you look at the chemistry periodic table, you'll find this element, which is atomic number 17, is actually a chlorine element. You'll find out that in that your periodic table, we have a chlorine that has an atomic number 17 and a mass number about 35.45. All right. Now, why is the atomic mass, not mass number, atomic mass 35.5? It's called average atomic mass. Average atomic mass, which means it is the average of the most abundant isotope of that element. It is the average of the most abundant isotope of that element. But if you want to look at the mass number, let's deal with the mass number now. This is the mass number of the isotope of chlorine 35. This is the mass number of isotope of chlorine 37. But let's say these chlorine element has about 75% in abundance on the Earth crust. 75. And let's say this guy has 25%. Now, if you want to see the average atomic mass of these chlorine elements, what you do is 75 over 100 times by 35 plus 25 over 100 times by 37. Of course, this will become a decimal of 0.75 times by 35 and plus 0.25 times by 37. We need a calculator now. So let's deal with this. 0.75 times by 35 is going to give me 26.25. So we have 26.25. So 0.25 times by 0.25 times by 37. That's going to give me 9.25. 9.25. If you add up the two of those, plus 26.25, that will give me 35.5. So we have 35.5. Now, if you look at the periodic table, you'll find out that in your periodic table we have 17, and then we have 35.45 as the atomic mass, not the mass number, atomic mass, or the average atomic mass, or the relative atomic mass. That's why you have these decimals in almost all the elements, or all the elements in the periodic table. If you talk about hydrogen, hydrogen is about has atomic number 1 and 1.008 as the atomic mass. This 1.008 is referring to atomic mass, not the mass number or the average atomic mass, atomic weight, whatever you call it. Now, but meanwhile, notice that the average of the two of those, or the relative of the two of those, is 35.5. If you take one from here, approximate it to this place, it will be 35.5. So with this, I want to explain again, atomic number is the number of proton only in the nucleus of an atom. And a mass number is the number of an individual isotope, the weight, the number of proton and neutron of an individual isotope. Let's look at the mass number of this guy here. This guy has proton, of course proton is 17, then neutron. If you want to get neutron, just do for me 35 minus 17. Of course, that will give me 18. So the neutron number there, the neutron is 18. Let's check up for this guy there. Over here, let's clean up this. It has a proton number 17. A neutron number will become 37 minus 17. 37 minus 17, that is 20. Okay, you can see there now is 20. Now, you can understand that this guy there, 35, is the mass number of the chlorine 35. 37 is the mass number of a specified isotope of chlorine 37. So you can notice that I have a proton 17, neutron 18. Notice over here, proton 17, neutron 20. But they are the same atom of element. But the average atomic number, average atomic mass, atomic mass or atomic weight is 35.5. Let's do just one more. And you know that we have